In our last video, we talked about how to simplify complex fractions, and we did a couple of examples, but just for a little extra practice, let's go through a couple more examples just for some extra practice. So our first exercise, this one's a little bit on the lighter end of the scale. We see this problem a lot where we just have a bunch of factors of powers of x. This is a very typical example. So to get rid of the complex fractions, the first thing we have to do is multiply the numerator and denominator by the LCD of these little mini fractions that you have all over the place. So those denominators are x squared, x, and x squared. So the least common denominator among all those fractions would just be x squared. And so good things happen if you multiply x squared through the entire numerator and the entire denominator. Namely, what it'll do is it'll kill off or get rid of all these little mini fractions, as you'll see. So let's do that right now. So we distribute the x squared through, we'll get an x squared minus 3 over x times x squared. One of the x's will cancel, but not both of them. So you have, oh, and I'm sorry, that's a plus, not a minus, my mistake. So it would be plus 3x, since one of them would cancel, minus 28, because both x squareds cancel for the last term as we distribute that guy through, divided by, and let's do the same thing in the denominator, we'd have x squared plus 12x plus 35. Okay, so a little bit of good news. This new fraction, this new rational expression we have, isn't a complex fraction anymore because there's not fractions within the larger fraction. But we're not done yet. We have one small thing left to do. The last thing you have to do is clean up or simplify this remaining thing that you have here. Now, if you have a quadratic over a quadratic, both of these guys are just kind of begging to be factored. Normally that's what you do when you have a quadratic like this. So let's see if these guys factor. First off, x squared plus 3x minus 28. So we need something that multiplies to 28, that or negative 28 rather, that might add to 3. Now you can make a little chart for your products that give you 28. I'm going to save us some time here. I think it's going to be 7 and 4. 7 times 4 gives you 28, and a 7 and a 4 could give you 3 if the signs were right. Now we do have to make sure the signs do work out. I think you would need minus 4 and plus 7 to get plus 3x. And lucky for us, negative 4 times 7 is negative 28. So that's factor by trial and error. In my experience, that's usually the fastest way to factor. The quadratic in the denominator will have an x and an x. Now we need two terms that multiply to 35 that also add to 12. So multiply to 35 that add to 12, I'm thinking 7 and 5. So it would be x plus 7 times x plus 5. And I know I went through that factoring kind of quickly, but that's not really the main point of this exercise, so I'm not spending a whole lot of time on that. All right, but now look, I've got the numerator factored and the denominator, and check it out. You have a factor in both the numerator and denominator of x plus 7. So you can cancel that right there. And your final answer would be x minus 4 divided by x plus 5. It cleaned up very nicely. This is not a complex fraction, so we got rid of the complex fractions by multiplying through by the LCD, and then we cleaned up our final result and got our final answer. So anyways, hopefully that was clear for you. All right, let's do one more. All right, the next one's going to be a little tougher. We got some uglier stuff going on, but that's okay. We can deal with it. So 12 over x squared plus 2x, all divided by 1 over x plus 2 plus 3 over x minus 3 over x plus 2. Blah, a lot of stuff there. So let's see if we can first off find the LCD. So I've got this denominator, this, and this denominator here. So I noticed this guy right here, first off, can be written as x times x plus 2. Notice you have a common factor of x with x squared plus 2x. So we've got x plus 2, and x plus 2's and x's all over the place. I think our LCD would just be x times x plus 2, I think. Let's multiply that LCD to the numerator and denominator. I'll write that in pink right here. Okay, multiply that to the numerator and denominator. When you multiply that to the numerator, it's pretty clear these are just going to cancel. So I think we would just get a 12. Multiply or distribute that LCD through the denominator. The first term, the x plus 2's would cancel. I think you'll get an x. The second term, the x's would cancel. I think you'll get an x plus 2. And minus the third term, I think the x plus 2's would cancel, and you would just get minus 3x, I believe. All right, last thing to do, and notice, by the way, the complex fraction is gone, but I think we still need to clean up that denominator a little bit there. Let me just do a little scratch work so I don't have to mess up my final answer. We'd get x plus 3x plus 6 minus 3x. Looks like the 3x and the minus 3x would cancel, so you just get an x plus 6. So here we go, final answer. I think we would get 12 divided by x plus 6. And I believe that's about it. Much, much simpler, much, much nicer. So again, same flavor. Hopefully you're seeing the process here. You get the LCD of the little mini fractions that are all over the place. Multiply that through the numerator and denominator. Your new answer shouldn't be a complex fraction anymore. You clean up that final answer or that final result that you would get to get your final answer. So anyways, hopefully those examples help you better understand simplifying complex fractions a little bit better.